So we're looking at the next aspect of drug interactions, and this is us trying to look at the pharmacokinetic interactions. So previously we looked at pharmacodynamics interactions, where we spoke about a drug could actually be enhancing, like if you give two drugs, they could be enhancing the effect of each other, or they could be suppressing the effect of each other. So now we're looking at the other aspects, which are pharmacokinetic interactions of drugs. So pharmacokinetics is basically you're trying to look at what the body does to the drug. Okay, so absorption interactions, sometimes if you give a drug with another drug or food substance and all of that, it could actually alter how they are being taken up in the gastrointestinal tract. So altering them could be that it is enhanced or depressed. You understand? The absorption could be enhanced or the absorption could be delayed. All right. The distribution interaction, so competition for plasma binding and tissues and all of that. So for example, if you give warfarins and non-steroidal anti-inflammatory drugs, non-steroidal anti-inflammatory drugs will displace warfarin from albumin. You understand? So you now have a lot of free warfarin in the body. I know warfarin stops clotting, so you can just bleed anyhow. You understand? So basically, these studies, they help you to know which type of drugs are compatible and which type of drugs are not compatible. The metabolism interaction, you're now trying to say if a bunch of drugs are being broken down by the same cytochrome P450, it's either when they are given at the same time, they could be broken down and it could actually enhance or decrease their effects. It's just like that. So for example, rifampicin, phenytoin, carbamazepine, they decrease the efficacy of oral contraceptives. So if I give these drugs and the woman is on oral contraceptives, if she has sex, she might actually even get pregnant. You understand? Then excretion interaction, you're now trying to see how these drugs will compete at the level of the kidney, okay, to which one goes out quickly. So a drug could actually decrease how another drug is being put out of the kidneys and the rest of it. So probenecid inhibits renal excretion of penicillin, so it will now lead to much of the penicillin being backed up in the body. Okay, so that's what we have for the pharmacokinetic aspects of drug interactions.